Machine learning, deep learning, and neural networks. An easy, quick explanation for curious rookies. Machine learning algorithms are responsible for the vast majority of the artificial intelligence advancements and applications you hear about. A task involving machine learning may not be linear, but it comprises a number of well-known steps: problem definition, preparation of data, learning of underlying model, improvement of underlying model through quantitative and qualitative evaluations, and presentation of model. Check out this video to understand how supervised, unsupervised, and reinforcement algorithmic models are helping to boost technology in areas as varied as healthcare, financial services, e-commerce, and transportation. Welcome back, folks, to another edition of the Awesome Sweetie Kiwi Show. How you doing today? I'm doing fantastic if you were to ask me. And if you are doing as marvelous as I am, go grab a cup of coffee or tea or vodka and let's roll. Today I want to talk to you about machine learning, deep learning, and neural networks. I'm giving you an easy, quick explanation for those of you who are curious rookies. What is machine learning? Machine learning algorithms use statistics to find patterns in massive amounts of data. And data here encompasses a lot of things. I'm talking about numbers, words, images, clicks, the list goes on. If it can be digitally stored, it can be fed into a machine learning algorithm. So machine learning is just the process that powers many of the services we use today. I'm talking about if you have recommendation systems like those on Netflix, YouTube, and Spotify, search engine like Google and Yahoo or Bing, social media feeds like Facebook and YouTube, voice assistant like Siri and Alexa, the list goes on. In all those instances, each platform is collecting as much data about you as possible. What genres you like watching, what links you are clicking, which statuses you are reacting to, and using machine learning to make a highly educated guess about what you might want next. Or in the case of a voice assistant, about which words match best with the funny sounds coming out of your mouth. Honestly, this process is quite basic. So the machine, you find the pattern, you apply the pattern. But it pretty much runs the world. That's in big part thanks to an invention in 1986, courtesy of Geoffrey Hinton, today known as the father of deep learning. We have a picture of Geoffrey Hinton on screen. You might want to see him. Great guy, very smart dude. What is deep learning? So I explained to you what machine learning was. Let's talk about deep learning now. Deep learning is machine learning on steroids. Think about it. It uses a technique that gives machines an enhanced ability to find and amplify even the smallest patterns. This technique is called a deep neural network. Deep because it has many layers of simple computational nodes that work together to munch through data and deliver a final result in the form of the prediction. What are those neural networks? Neural networks were vaguely inspired by the inner workings of the human brains. The nodes here are sort of like neurons, and the network is sort of like the brain itself. But Geoffrey Hinton, published his breakthrough paper at a time when neural nets had fallen out of fashion. So no one really knew how to train them, so they weren't really producing good results. It took nearly 30 years, 3 decades, for the technique to make a comeback. And nowadays, you sure bet it did make a great comeback. I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Kiwi. We are talking today about machine learning, deep learning, and neural networks. I'm giving you a quick explanation for those of you who are curious rookies. What is supervised learning? Before I continue here, let me quickly say that if you love this content, you believe it is adding value to your life, you might want to go ahead and smash the like button and share this content, and also comment below. What do you experience machine learning? Do you work in the industry? And also, please subscribe to our channel so that when we release the new show every single day, you are informed. Turn on the notification bell, please. What is supervised learning? I've spoken about supervised learning, unsupervised learning, and reinforcement learning in the intro to this video. What is supervised learning? You need to know that machine and deep learning comes in three flavors. As I said, supervised, unsupervised, and reinforcement. In supervised learning, the most prevalent, the data is labeled to tell the machine exactly what patterns it should look for. Think of it as something like a sniffer dog that will hunt down targets once it knows the scent it's after. You see those sniffer dogs they use at the airport to look for banned substances, for example, right? So supervised machine learning algorithms are trained using label data. Hence, they are called supervised. It is like parents trying to help kids learn what behavior is good and what is bad. Good and bad are labels attached to the historical data points related to behavior. Once the training phase is accomplished, the algorithm will apply the good and bad labels to the new data inputs to either do predictions or classifications. That's what you're doing when you press play on a Netflix show. You're telling the algorithm to find similar shows. Now let's talk about unsupervised learning. In unsupervised learning, the data has no labels. Simple as that. The data has no labels. So the machine just looks for whatever patterns it can find. This is like letting a dog smell tons of different objects and sorting them into groups with similar smells. Unsupervised techniques are not as popular because they have less obvious applications. Interestingly, they have gained traction in cybersecurity. We'll talk about that in another show. It's very interesting how unsupervised learning is helping law enforcement and companies break down or crank down on cybersecurity. It's fantastic to learn about that. What is reinforcement learning? So I spoke about supervised learning, unsupervised learning, and now I'm talking about reinforcement learning. This is basically the latest frontier of machine learning. A reinforcement algorithm learns by trial and error to achieve a clear objective. It tries out lots of different things and is rewarded or penalized depending on whether its behaviors help or hinder it from reaching its objective. This is like giving and withholding treats when teaching a dog a new trick, right? So reinforcement, so you can have positive reinforcement or negative reinforcement. Reinforcement learning is the basis of Google's AlphaGo, for example, the program that famously beat the best human players in the complex game of Go, if you remember a few years ago. All right, I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Kiwi. We are still talking here about deep learning, neural networks, and machine learning. Now, we've talked about all these things. It's beautiful. Now, you might be asking yourself, what are the applications? You want concrete applications, practical examples of where machine learning is used. I've talked about Netflix, and when you go to Amazon to buy stuff, they give you a recommendation. Now, let's get out of the world of the internet and see in real life how machine learning is being applied to regular industries. Effective learning systems provide insights that help businesses make efficient decisions and outdo their competitors. Let me give you some of the industry use cases to give you an idea of where ML, machine learning, is applied. Healthcare, for example. So the technological enhancement of the 20th century have given the industry the boon of wearable devices and sensors that help users assess a patient's health or activity in real time. Such technology also has the potential here to improve healthcare research and help experts assess and analyze enormous amounts of research and medical data to get valuable insights, which in the end contributes to improved diagnosis, treatment, and efficiently expedite life sciences research. So the application of machine learning in the early stages of drug discovery has a high potential in the initial screening of drug compounds and to predict their success rate based on their respective parameters and factors. Let's talk now around financial services. The banking and financial industry applies machine learning for various purposes, two of which stand out the most. So acquiring reliable insights from data for risk management and prevention of fraud, for example, by identifying high-risk profiles, improving the efficiency in terms of compliance and reducing the risk of misconduct. Regulatory compliance in the financial services sector has tremendously benefited by the application of machine learning. For example, automating the tracking regulations and amendments. So you have, for example, the machine learning will help a bank map the typical workflow of a regulatory specialist by automatically sectioning, summarizing, and assessing the areas of impact of a regulatory document in its various versions. And the ML item here may continuously monitor for changes and updates of different financial regulatory bodies, proposals, initiatives, as well as rules and regulations, consultations, and discussion papers issued by the relevant authorities. Think about how much money banks and other financial institutions are saving by using machine learning algorithms in their operations. That's just fantastic. Let's talk about e-commerce. Now, e-commerce, of course, I've already spoken a little bit about it, but let's just again talk a little bit about the advantages and the applications of ML in e-commerce. So, have you ever used an e-commerce website to order online? I spoke about Amazon. You have Shopify. You have all those eBay. You have all those big companies. All those big e-commerce websites, they efficiently deploy machine learning algorithms to analyze your buying patterns and push the other most relevant items customized and unique to every user. So this ability to acquire data, evaluate it, and analyze it to personalize a user's shopping experience is certainly a game changer in the retail industry. So recommendation engines are one such example. The fourth industry where machine learning has been applied nowadays is transportation. Think about it. The global transportation infrastructure relies on making transportation efficient by predicting problems and solving the same before they arise. So machine learning in the transportation industry plays a key role here in identifying such trends and patterns to improve predictive capabilities. Now, this is machine learning. It's not a big field yet. It is a very narrow field. But in 5-10 years, according to experts, it will become part of nearly every software application and will bring benefits to every industry in our daily lives. It will replace manual, repeatable processes. This is a must for us to understand the concept of machine learning and apply it to the improvement of humanity here. So if you can see, I only give you here 4 industries, but in the next 5 to 10 years, according to all experts, the machine learning will be applied to the whole continuum of human activities and economic activity. All right. So this is it, folks. This was a quick explanation, easy explanation of machine learning, deep learning, and neural networks. Let me give you a quick recap of what I spoke about today here. I gave you a definition of machine learning, definition of deep learning, an explanation of neural networks, explain also supervised learning, unsupervised learning, reinforcement learning, and finally I gave you applications, 4 examples of applications of machine learning in the industry. I will be right back another time, and I wish you a wonderful time. Thanks so much for listening to me. Until then, stay marvelous.